Okay, I'm going to be doing problem number 4 on paper 2 kind of quickly. Try to get it in 10 minutes here. So I see our triangle is not a right triangle, and the dimensions are all up here. The only information that's additional is the race starts and finishes at point A. That may be relevant later on. Okay, so I'm looking at this, and I know I'm not going to use SOHCAHTOA because it's not a right triangle. I just got to decide, is it law of sines or cosines? It's law of sines if I have an angle on the side across from it, and I don't have that side. I'm actually finding that side. So I know it's law of cosines. There's two law of cosines. One of them is for the side, and one of them is for the angle. So I'm going to use the one for the side. So the side squared equals the other two sides squared, blah, blah, blah. Plug it in and go. Okay, so we're going fast. So there's my formula. Plug in my numbers. Take the square root. And you're doing 3 sig figs. That would be 1,320. So it says calculate the total length of the course. If you don't read the question, if you're just trying to get focused on finding AC, you're going to miss a point. So you're going to add 700 plus 900 plus 1,320, and that would be your total. Okay. Part B, calculate an estimate of the winning time. Give your answer to the nearest minute. There's a rounding thing here. So B, total time. We know that the speed is 1.5 meters per second, and we are going 1,320 meters. Distance equals rate times time. So the distance is 1,320. The rate is 1.5 meters per second. So if we divide 1,320 by 1.5, that gives you an estimate. Do that quick. $880. That is in seconds. So I'm going to divide it by 60. It says to the nearest minute, so 15 minutes. And you would want to write the 14.6 repeating and do this little deal. Okay. Part C, find the size of angle ACB. Now I can use sine rule because I know that side is 1,320. Move this down a little bit. So 1,320 over the sine of 110 equals 700 over the sine of angle ACB. And to solve this, I'm going to cross multiply and take 700 times sine 110 divided by 1,320. Since I'm finding an angle, I do the second sine of my answer, 29.889. Make sure there's not a rounding. So find the size. So we found the size. So 29.9. And I want to show you on the mark scheme. It says accept 29.9 if you use the 3 sig fig value. So that's fine as long as you use that all the way through. That's why you show your work. Okay. It's estimated the fastest boat, to comply with safety regulations, the area inside must be kept clear of other boats, and the shortest distance from B to AC must be greater than 375. Okay, so I'm going to go to my picture, and B to AC, the shortest distance is at a right angle. So I'm going to put my 29.9 right here, and some of you might have had 30, depends on if you use the exact. So let's go ahead and, just for ease here, we're going to change this to 30. So these two add up to, these two add up to 140. That means this is 40. I can fill that in. So we're going to see if we have that right distance, and we're also going to, that's going to be the compliance, and we're also going to find the area. The area, we're going to use the side angle side rule. So 1/2 AB sine C. I need to find the area of this big triangle. 1/2 700 times 900 times the sine of 110. I'm using the original information. I could use other information, but I know with the original information, if I made a mistake, then I'm using the right values and not my own. So that's 296,003.1755. So that's my area. If you want to do 3 sig figs, 29600 meters squared. Okay, and I'm not using the sheet anymore. I can't fit it all on my screen. Okay, part E, does it comply with safety regulations? I would draw this triangle on my working, and I'm going to figure out this is 30 or 29.9 if you use that. This is 900. I need to find this. Opposite hypotenuse. Sine of 30 equals h over 900. So to solve, 900 times sine of 30, it's going to be 450. So with a reason, compliance. Well, my number is bigger than 375. So looking at the reasoning, 450 is greater than 375. Thus, the course complies with the safety regulations. Notice R1 there. Make sure that you are giving a reason when it asks for a reason. Okay? The race is filmed from a helicopter H, which is flying vertically above point A. The angle of elevation from H from B is 15 degrees. Okay, so we have A and B, and then the helicopter is like this. There's a right angle, it's right above it. Angle of elevation is always the angle with the ground up to what you're looking at. If they gave you angle of depression, that would be the same as angle of elevation. Calculate the vertical height of the helicopter. Okay, so what do I need to know? I need to know this side is AB is 700, so I'm going to plug that in. I need to find this height of the helicopter. Opposite adjacent, TOA. Tangent of 15 equals h over 700. So 700 times tan 15, 187.564444, which is 188. Calculate the maximum possible distance from the helicopter to a boat on the course. Okay. The furthest place the helicopter can be to a boat on the course. So the helicopter is hovering at right above A, and we're trying to figure out the furthest distance from any place on the course. So I'm going to let you check this answer because I'm running out of time. You notice it is 1,330. That is because we